Okay, very good afternoon to all of you in this physics session of waves. As you know that these are all very brief sessions, 10 to 15 minutes per session. So in one session we'll take up a small topic. I'll teach something about the topic. I'll give you about 4-5 questions for homework, and you should ideally try to submit the homework by 9 p.m. of the next day. If you do that, then you can engage in a meeting and discuss the homework with me. So today the topic which I have picked up is intensity and loudness of sound. So what exactly is intensity of sound? It is energy passing through a unit area placed perpendicular to the direction of propagation. So you know that sound waves propagate as longitudinal waves in air, and while the longitudinal wave is propagating, so sound wave in propagation of sound wave is basically energy in motion. You know, energy is sound energy is being transferred from one point to another. So when you say that the sound is propagating, that means the sound energy is moving in a particular direction. Then if you imagine a unit area depending on what system you are using, if it is SI then 1 meter by 1 meter. So if you imagine that there is a unit area which is placed perpendicular to the direction of propagation, okay, there is a unit area perpendicular direction of propagation, then the energy passing through that unit area is called intensity, right? So suppose let us say that there is a source of sound, and sound energy is propagating like this. So if you keep a unit area, okay, if you keep a unit area of 1 meter by 1 meter, then the amount of sound energy passing through this unit area per unit time. So the amount of sound energy passing through this unit area per unit time, and this unit area is placed perpendicular to the direction of propagation, that is known as intensity. So energy, you know, it is measured in joules, and per unit area, so meter square, and per unit time. So that means that the SI unit of intensity is joule per second meter square. That is the SI unit. So joule per second, all of you know, is watt. So the SI unit of intensity of sound is watt per meter square, right? Now there is a very important relation between the wave nature of sound and the intensity of sound, that is amplitude. You know that every wave has some characteristics: amplitude, frequency, wavelength, time period. So the intensity was found to be proportional to the square of amplitude. So intensity is proportional to the square of amplitude. So the intensity of sound is denoted by a capital I, and it is proportional to the square of amplitude. Intensity is proportional to amplitude square. So this is the relation, right? It is proportional to amplitude square. So if you, by the way, in day-to-day life we don't use words like intensity. We say loud sound. We say that the sound is very loud. The louder sound means more intensity. So that means what? If you were to look at the wave of a sound wave, the wave curve of a sound wave, then the amplitude is high, that means intensity is high, it is loud. If amplitude is less, intensity is less, that means it is comparatively less loud, right? So intensity is proportional to square of amplitude. Now the thing is that suppose this is a point source of sound. Suppose S is a point source of sound. Now the thing is that what do you mean by point source of sound? Now this sounds a little confusing. What is this point source of sound? See, actually what we say is that sound or light, the source from where it is coming, if you say it's a point source, that means it will equally send energy in all directions. That is the only reason we call it a point source. So if you say that, you know, this is a point source of sound, we use this in light also, point source of light. So if you say it's a point source, that means it will send energy equally in all directions. That's why we say point source. So if this is a point source of sound, and you know that the source will have some power. Like if you say that sound is coming from a speaker, so the speaker will have some power, 200 watt speaker, 500 watt speaker, whatever it is. So suppose the power of this speaker is P, then suppose the power of the speaker is P, then at a distance R, okay, at a distance R, the intensity will be P divided by 4 pi R square. So at a distance R from the speaker, the intensity of sound will be power divided by 4 pi R square. So this is the formula for intensity, power divided by 4 pi R square, right? Because it is a point source, so it will give sound energy equally in all directions. So if you draw a sphere centered at S, if you draw a sphere centered at S, sphere of radius R, then the surface area of the sphere will be 4 pi R square. So the intensity at a distance R will be power of the speaker by 4 pi R square. Now the problem what the scientists were facing is that this intensity in day-to-day life calculation, this intensity comes to around 10 to the power minus 12 watts per meter square. So in day-to-day life situation, like two people are talking, etc. So it's in the range of 10 to the power minus 12, which is very, very low. So there was a debate that maybe intensity is not, it's not a quantity which we can relate to in day-to-day life because it seems to be too small, 10 to the power minus 12. So the scientists decided to try something better. So that is called loudness. And loudness, they decided to have a unit called decibel. So the loudness of sound is measured in decibels. Okay, the loudness of sound is measured in decibels, and the symbol of decibel is beta. Okay, beta is the symbol of decibel, and the formula for that is 10 log I by I0 to the base 10. So what is the unit of loudness? Decibel. This is a symbol, and it is 10 log of I by I0 to the base 10. This is the unit of loudness, decibel, and this is how you measure it, right? Now I0, I told you I0 is the reference value. In fact, this is what we call I0. Okay, this is I0, 10 to the power minus 12. This is I0, 10 to the power minus 12 watt per meter square. This is I0. So you put I0 here, you put I, whatever is the value, and you do this calculation, and you will get something which you can relate to in day-to-day life. Just to give you an idea that how we can relate to this value, just to give you an idea. Suppose if two people are talking to each other, let us say two people are talking to each other, and but the voice is in a whisper, like they are talking, but they are talking in a whispering voice, then it is coming to 10 decibel. Okay, suppose it is normal conversation. So if it is in a whisper, then it will be 10 decibel. Suppose it's a normal conversation, not a whispering voice, then it will be 60 decibel. And suppose, let us say, I want maximum tolerable sound, then it will be 120 decibel. 120 decibel is really high. Just to give you an example, it is rare to have sound of 120 or more decibel. But just to give you an example, if you are standing on a runway of an airport when the aircraft is just about to take off, so that is in excess of 120 decibel. That is really loud sound. So I mean, it can shatter the eardrums. It is more than 120 decibel. Okay, it can shatter the eardrums. So maximum tolerable sound is 1. So you can see that these values 10, 60, 120, for example, during Durga Puja, in our city, Kolkata, you will find that the traffic police keeps saying that the sound should not cross 90 decibel. Near hospitals, there is a rule that you cannot have certain more than a certain decibel amount of sound near hospitals. Durga Puja 90 decibel is the limit. Otherwise people will burst crackers indiscriminately. So decibel we can easily relate to. So this is the total discussion for today. So what all did we discuss today? Intensity and loudness of sound. Intensity is energy passing through a unit area per unit time, perpendicular to the direction of propagation. So suppose the sound is going like this, and there is a 1 meter by 1 meter square. So the amount of sound energy passing through this 1 meter by 1 meter square in 1 second, that is called intensity. And in day-to-day life, the value comes to 10 to the power minus 12 watt per meter square, which is really low. Intensity is relatable to the wave nature of sound, that it is proportional to square of amplitude. If you have a point source of sound at a distance r, the intensity will be the power of the speaker by 4 pi r square. So this is the value of the intensity, that power by 4 pi r square. And the fact that I0 is a very small value, this led the scientists to conclude that we should have a more relatable way of measuring the loudness of sound. So they went for something called decibel. Decibel is 10 log I by I0 to the base 10. I0 is 10 to the power minus 12. I is the intensity which you want to measure, and this gives you a figure which is more relatable in day-to-day life. Like whispering voice is 10, normal conversation 60, minimum tolerable sound is 120. So this is the theory for today, and as usual I'll give you some homework questions now. Okay, the first homework question is, sound level at a point is increased by 30 decibel. Okay, the sound level at a point is increased by 30 decibel. By what factor is the pressure amplitude increased? So if the sound level at a point is increased by 30 decibel, by what factor is the pressure amplitude increased? This is the first homework question for today. Okay, by the way, pressure amplitude, you take it to mean amplitude. Okay, when I say pressure amplitude, that is because longitudinal waves, we can write their wave equation in terms of pressure as well as displacement. So I have written pressure amplitude, so you just take it to mean amplitude. By what factor is the amplitude increased? Okay, question number 3. Sound level 5 meters from a point source is 40 decibel. So what is the sound level 50 meters from the source? 5 meters from the source is 40 decibel. What is the sound 50 meter from the source? That is question number 5. Question number 3. Question number 4. If the intensity at 5 meters from the source is 10 to the power minus 8 watt per meter square, what is the intensity 25 meter from the source? Question number 4. Intensity 5 meters from the source is 10 to the power minus 8 watt per meter square. What is the intensity 25 meters from the source? Okay, question number 5, the last question. If there are 50 students in a classroom and they make a sound of 50 decibel, 50 students they are talking together and the sound is 50 decibel, then 100 students will be how many decibel? Assume that all students are talking with equal intensity. So these are the 5 homework questions, right? And you can submit it anytime before 9 p.m. tomorrow, and after you submit it I will engage a meeting and I will tell you whether your homework is correct or not. So I will conclude this session, and those who are submitting, I will clear your homework tomorrow after 9 p.m. Thanks a lot. I will conclude the session. Bye all of you.